Welcome to the UC Delta Kite Project. The goal of this project was to create a kite with 3 different tail designs and then test these 3 tails to find a correlation between handling qualities and tail designs. In order to do this, we first had to come up with system requirements in order to successfully complete the project and create what is wanted by the customer. As you see here, these are just a few of the system requirements that we had along the way, some already completed and some yet to be completed in the pre-flight check. As far as materials went for the kite and tails, we had to keep it under a budget of $50. For the main kite material, we used a ripstop nylon fabric. The structural components were made out of 1/4-inch dowel rods, and then the string that we used was taken from a store-bought kite. This store-bought kite allowed us to fly it and see how it handled so that we could get a hang on the feeling of flying a kite before we created and tested our own that we had made. These photos here are showing the different design features that we came up with in order to create what we thought would be the best kite platform to test our tails on. When we were constructing our first models like those in these pictures, we just held things together by staples, but for the final product we sewed everything together. The dimensions of the kite were somewhat restricted by our building materials, mainly due to the fact that we only had 36-inch dowel rods. Our original plan was to use 48-inch dowel rods. For one of the pieces necessary, however, Jose will soon be showing how we got around this obstacle. Now we come to the tail designs. Our first tail that we created consisted of 6 2-inch wide ribbons, each 36 inches long. All 6 of these ribbons were then attached at the center of the kite, where we thought it would help the most. For the next design, we just took 2 of these same 36-inch long pieces and attached them at the wingtips on each side. This we thought would create more roll stability. The final tail design seen here was simply a 12-foot piece of 6-inch wide nylon skirting. We hoped this tail would have the best stability due to the extreme surface area of the tail. The obstacle stated earlier that we faced was that we needed one 48-inch dowel rod for our spine, but we only had 36-inch pieces. Here Jose is showing how he created a 48-inch piece using 2 24-inch pieces, a nail, glue, tape, and a grinder. Basically, he cut 2 24-inch pieces, then drilled a small hole in each end. Next, he took a nail and ground off the head. He then inserted the nail into the dowel rods and used it as a connecting pin. Then he glued and taped the conjoined ends for extra stability. In an ideal situation, every part would have been made specifically for the sole purpose of its role in our kite. However, this is very unrealistic in our case because we had a cost constraint of $50. Our total cost of materials was less than 25 cents away from this. Once this final structural component was completed, I then began to sew the kite together at all of its necessary points. Here I am sewing on the last pockets where the structural cross member will be placed. Once all of this was complete, we then could start going through our pre-flight checklist in order to make sure that everything was complete and our product was safe to fly. Finally, we make it to testing day. Here we are just flying our kite alone with no tail. For safety reasons, we made sure that we were clear of all obstacles and people that could be injured by our kite if it were to crash to the ground or anything else unexpected. To land each time, the pilot would simply let out the line so that the kite loses its lift and it gently comes to the ground. Here on the first tail testing, the results were somewhat surprising. We expected this tail to add moderate stability to the kite. However, in the testing that took place, the kite flew unstable with this tail attached. It created a jerking sensation that I as the pilot couldn't counter. Increasing my speed walking, however, I could fluctuate elevation, which was one of our figures of merit. The second kite here handled much better than the first. The tails at both ends allowed the kite to maintain a more steady course, and this design did not have quite as much jerking. Just like in the last test, I was able to adjust altitude by increasing my speed as well. Testing our third tail as seen here gave us by far the best results of all 3. Like predicted, this tail created a lot of drag and therefore had a lot of force that was necessary to throw it off course. This kite was way more stable, and the instability that it did have basically was just roll from the central spine. Elevation was also easily controlled by adjusting my walking speed. Because we then knew that the second 2 tails flew the best and that the flaw of the third was the strength of the second, we then did a test flight with both tails 2 and 3 attached, and we saw by far the most stable kite that we had flown in our testing. The unstableness of the third tail was countered by adding the drag on the ends of the wings with the second tail design. This basically created a greater moment of inertia for the kite to roll about the central spine. In all, the project was a great success. Much was learned, and we had great fun in doing so.